Geometry. We are continuing our Unit 4, talking about special characteristics, qualifications of triangles. And we're going to start with learning something new called a midsegment. Who can tell me, what do you think a midsegment is going to be? Damien?
It's in the middle.
In the middle. Very good. Kylie? Do you remember what you said earlier?
Something to do with the midpoint.
Okay, very good. Arlene?
Maybe the segment is in the middle between two segments.
Ah, very good. Claire?
The middle of a segment.
Anthony?
Has to do with the triangle.
All right, all good things that you said. A midsegment is a segment that connects the midpoints of two sides of a triangle. A is a segment that connects the midpoints of two sides of a triangle. Okay. So, drawing a picture of this so we can visualize what it looks like and talk about the midsegment theorem. We got a triangle here. We're going to kind of try to make it not equilateral or isosceles, kind of give it a little bit of distinguish there. So a midsegment, as our definition says, it connects the midpoint of two sides of the triangle. So I'm going to put the midpoint of this side here. Folks, quiet please. And the approximate midpoint of this side over here looks like right about there. And then the segment that connects them. Okay, so that segment in red there is the midsegment of the triangle. And let's get some labels here. We'll call this A, B, C, and we'll call this D and E here. Okay, so just the fact that is a midsegment, right? And by definition, it connects the midpoints of two sides of a triangle. What can you already tell me? What relationships can we start to mark here or draw in here, just knowing that that is a midsegment? Sophie? So if we make all possible midsegments, yes. Okay, we're not going to do that yet because it's going to be very, very cluttered, but I'll get back to what Sophie said in just a little bit. What can we mark on here as true? What conclusions can we make? Just knowing that DE is a midsegment, and just looking at the definition, connecting the midpoints of the two sides of the triangle. Becky.
DB and DA are the same.
Okay, so
AE and EC are the same, and BC are parallel.
Okay, so we can conclude that AD and BD are congruent, right? Because if point D is the midpoint of that segment, we talked about midpoint before, it's the middle of a segment, we can say that AD and BD are congruent. We can also say that AE and CE are congruent. We do have to mark them with two tick marks because they are different lengths than AD and BD there, okay? But because point E is a midpoint, we can conclude that as well, right? He went one step further, and this is part of what the theorem actually says here. He concluded that DE is parallel to BC, which is correct, okay? So the theorem kind of has two parts to it, two things that you need to know. Number one is a midsegment is parallel. We'll call it the third side. It's the side that the midsegment doesn't connect, okay? But it's parallel to the third side. And a midsegment is half, yes, the length of the third side. Okay, so the midsegment and the third side have a couple of connections here. Number one, they are parallel, as we've marked for you there. And the midsegment is half the length of the third side. So whatever DE, whatever that measurement is, we know it's going to be 1/2 the length of BC. Okay? The length of that mid segment is 1/2 the length of that third side. And since we have those parallel lines there, what also does that now bring into play? What other sorts of relationships can we bring? Yeah.
Wait,
Catherine.
I have a question.
Yeah.
Why is it 1/2?
Why is it 1/2? It has to do with the fact that it's connecting the midpoints here, and midpoints being half of those sides. Okay? Did you hear what I said? Because it's connecting the midpoints of those two sides, and mid all having to do with middle half, everything like that, its length will be half the length of that third side. So it has to do with the fact that it connects the midpoints. If we had a segment just going across a triangle, in a more random place, not connecting the midpoints, that obviously would not be half the length of the third side. Or if it connected the two segments way down here, that would not be half the length of the third side. Okay, it's because it connects the midpoints of those two sides that's half the length of the third side. Right? Sophie brought up earlier the fact that it'll create a new triangle. If we did connect all three, all right, doesn't work.
It was not me, bro. You're having so shocked me.
Joey, you can scoot on
Why does it
back.
always have to be me?
You can scoot on back. Not working today. If we connected all three midpoints, and again, I'm just kind of guesstimating here, and about there, we would get another triangle within a triangle, right? And if we continue to do this, if we made the midpoints of these three sides and continue to connect them, we would get a triangle inside it. We can continue to do this forever, okay? And it would continue to spout all those relationships, right? Connect, everything like that. No, I cannot. But back to kind of what we have here. The fact that DE and BC are parallel, yeah, where are you going?
So is it true in a sense that triangles can be infinite that way, that you can keep creating triangles inside a triangle?
Yes, and the reason why, do you remember talking about asymptotes in one of the previous math packets where something can infinitely approach something but never touch it? The idea that you can always take half of something, in theory, you start with a piece of paper, tear it in half, tear each half in half, half and half again, half and again. Continue to do that. In theory, you'll never run out of paper, right? Because you can always take half of a quantity. So because we're connecting the midpoints of these triangles, in theory, okay, it's very difficult to do because our, get very small there. But yes, you can continue to work your way down with those triangles forever. Back to my question about parallel lines though. DE and BC being parallel, what concept, what do we bring back into play here? Kylie? Transversals. So we now know that AED is congruent to ACB because they're corresponding. We have triangles here as well, or congruent angles there as well because they're corresponding. All those things, that toolbox just keeps growing, and we can use all sorts of these relationships. But specific to a mid-segment, these are the two things that are most important for today. Okay? Parallel on the third side and half the length. Questions so far? Okay. So given the diagram here where we do have a triangle inside of a triangle created by connecting the midpoints there, finding AC, if AB is 72, find EF. If DF is 45, find EC. And what is the perimeter of triangle ABC? Let's just start with AC.
Oh yeah, got it.
Joey.
AC would be 102.
Well done, right? Because this midsegment here is half the length of that third side. Therefore, if it's marked as 51, then 51 times 2 would be 102. Okay. So the next one, I give you the entire segment, ask you to find EF. kind of just working with those theorems there. If you've ever driven past a construction site where things are still in kind of the more infancy stage, you'll see triangles used a lot. They're a very strong shape. Those of you that have done some E3 engineering stuff at various high schools, maybe camps or things, you know the importance of triangles. And so in construction, why does this matter? Well, if you want to, create a structure that's going to fit together, right? And be strong and essentially work, a lot of these things come into play here. Okay? So, in groups of your choosing for about 5 minutes, fill out this page. We will discuss shortly. Okay, back at it, going over some answers here before we break the day. Damien, what I want from you? Your attention. So we already did the first one. If AB is 72, find EF. So AB is the entire side here. That's 72. We're looking for EF, which we know is the midsegment. Therefore, class in unison, what is EF?
Something.
36. Okay. It is half. The midsegment is half the length of that third side. If DF is 45.
51.
If DF is 45, find EC. Max,
45.
why is it 45?
Because DF is like half of BC.
Right.
I can actually explain it. EC is half of BC.
So we know that DF is half of BC, which would make BC 90. Anthony, what did I ask you for earlier? Boys, no. But because E is the midpoint, we know that that point E separates us into two congruent pieces, leaving EC 45. So that's a connection we didn't say earlier. We just said that it's half of that third side, but the two segments the third side is divided into, each of those are congruent to the midsegment itself. Damien. Again, finally, what is the perimeter of triangle ABC? You were given AC, or we found it, 102. We found BC to be 90. AB was given to you. What's the final perimeter? Jack?
It is 164.
164 is the sum of those three things. I don't think that's right.
260, yeah!
264
There's literally 100 in there.
looks a bit more accurate.
164.
Catherine?
You really give me what are you doing?
Catherine, go ahead. Okay. Guys, boys. Stop. I'm gonna let the rest of the class work in groups. I'm gonna let the rest of the class work in groups, and you'll be individual. Okay? I want to splice this conversation for conferences when I say your name all these times, so that we can pass that message along.
David was all talking about peace control.
It's down here.
We're supposed to do that one?
Yes. Finish the page with the direction. In the diagram below, UV and VW are midsegments. So we have UV and WV as midsegments here. And it says find UV and RS. What'd you do? Good.
I knew that 57 was congruent to, VW was congruent to UR, and also US.
I want to mark that in blue instead so we can identify that. Okay? So that's going to be 57 there.
And that's 57.
US is 57 there is well, the whole thing, which represents RS, right, is going to be 114.
Yeah.
Double what 57 is. Okay? And then finding UV.
How is US 57?
So if this is the midsegment of RS here, that means that 57 is half of that third side, okay? Which makes that RS 114, because you just double what the mid-segment length is. Or, knowing that the mid-segment is equal to half that third side, okay? Each piece is going to be congruent. Like, guys, it's so frustrating to have to stop. as often as I need to stop to correct behaviors that as 8th graders you know you should not be doing. Okay? And now unfortunately we're out of time, so I've got to let you go here. There is no homework tomorrow, but just know that a number of you are leaving in a very frustrated state of mind.
Yeah, I'm not RW.